Hi guys, my name's Andy Bennett. I'm with Next Centre. Roel Frene's with one of our partners out of EMEA, and we're going to talk to you about Next Centre Stretch Metro Cluster. Basically, Roel delivered a POC with us as a beta test of a new product that we're coming out with, and Roel's going to share with you some of the deliverables on that, where the opportunity came from, what we actually delivered in part of that solution. But what I'm going to talk to you about first before I hand over to Roel is the key features that we are developing in Stretch Metro Cluster, which we are announcing here. We did a little preview demo at our EMEA event where we did a live demo of the Stretch Metro Cluster. And basically, we're giving you some more information about that product now, and product marketing will be disseminating the actual information on the details of the product further. So what is Stretch Metro Cluster? It provides high availability clustering across geographically disparate sites. They can be 1 kilometre apart, they can be 20 kilometres apart, they can be 30 kilometres apart. It's a non-disruptive failover product for block and file storage services. So it goes hand in hand with our unified storage appliance. You can choose between manual and automatic failover between sites. So we actually give you the opportunity to choose that. It uses ZFS file system block level mirroring to deliver optimal performance of that type of distributed cluster. We do end-to-end checksumming as a byproduct of our underlying ZFS file system on every transaction that we send across your Stretch Metro cluster. We use volume service locking to prevent the traditional exposure that you can have in some Stretch cluster designs to split brain between remote sites. Okay? One of the features that we have that we think is world-leading is we can do triple site mirroring with end-to-end checksumming. Okay? Some of the key features that we have is our tech team have done some development within our core product to provide additional functionality for performance tuning for this type of environment, which is our local read weighting. And combine that with our hybrid storage pool and SSD caching. We use that to accelerate the performance of our Stretch Metro cluster to the sort of levels that you don't generally see in distributed WAN type clusters. Okay, so I'm going to hand you over to Roel. He's going to tell you a little bit about his company and the great work we did together with them.
Thank you, Andy. So my name is Roel Frene. Difficult name in English. Sorry about that. I've got a server and storage company already for 12 years going on. And we started with Next Centre in 2009 with simple configurations to replace actually our business with a company I won't mention here. It's not worth mentioning it. So, and then a sudden moment, a customer of me asked me some specific questions for storage between two sites. It's a cloud company, and it's called Bennett. It's Belgium Network Solutions. And they have a huge amount of companies running virtual machines in their data center. And they want to be data center proof. Now, to do that, you have to have a synchronous link to your data in two sites, which is actually not easily done nowadays. Then I was talking to Andy about it, and he said, have a look at CoRate. I said, that will be an adventure, I think. And actually, thanks to the good support of CoRate and Andy, we could establish a proof of concept to the customer to prove that it worked. Now, the customer was aware that this was the first time ever done it. So it was a huge risk for me, for Andy, for CoRate, and also for the customer to do this, to try this. And so we head on, and we want to be in a triple mirror by the end of this year across whole of Belgium. So Belgium is not so very big. I think if you ride from the one part to the other part of Belgium, it's only 300 kilometers. So the main advantage of that is there's a lot of fiber over there. So we have dark fibers between data centers, no point at all. So in the golden triangle of Belgium, we have Brussels, Antwerp, and Oostkamp. where he has a dark fiber ring that everything is connected to. So at the end of the year, we want to have his storage mirrored synchronously over those 3 sites in an HA environment. So he can fail over his virtual machines, but also his storage to different sites. So if a plane crash in Brussels near the airport crashes the data center, because it's right next door, then he's not harmed. So he can carry on another data center. Then there's another in Antwerp, is also next to an airport. So if there also crashes an airplane, sometime that happened 10 years ago, they also have Oostkamp, and there's no airport around. So
Only a nuclear site.
no, that's also 50 kilometers away. So all the 3 data centers are more than 50 kilometers away from each other. So it could be, there's nothing more that we can do to prevent data loss.
How often do plane crashes would really happen at the airport?
Well, in Europe it doesn't, but in the United States something different.
Usually happens on a river, right?
Yeah. And European pilots, they land on a river, in the Hudson River. Somebody else uses something else to land on. But so Bennett came to me and said, I want some technical requests. So I made a list. So I want high available iSCSI service between 2 head nodes. I want to distribute synchronous data between 2 physical sites. No, the 3 physical sites is actually what we're going to present him as a favor, because we could do this for him. So we said, now we're going to triple it. So we were very happy with that customer. So the first setup was 15 kilometers. And that worked all right. And the second was 40 kilometers. So actually the first question was 50 kilometers. So the client grow his demand like we proven the concept. The failover time just between the 2 data centers must be less than a minute, and may not crash any VMs on it. VMware storage motion and vMotion between the 2 sites. So I actually wanted to move a virtual machine from one data center to another data center. And also the storage, he wants to move it. So he can run his VM in data center A while his storage is in data center B. Very high ops. Minimum was 10,000 IOPS. We have more. So high performance, minimum 200 megabytes a second was a need. Actually, he took his Equalogic that he paid for around 50,000 euros. What could head out of that, and that came to us. That's my minimum requirements. It has to be data center shutdown proof. So if a plane crash, electricity went out, you name it, a flood, must be secure. And he wants to start with the proof of concept 11 terabyte. But of course, with 11 terabyte, he wants to grow as much as he can. So he said 500 terabyte. Now, that's a lot of data in Belgium. So I think in the near future, it can even be more. I think an example would like a 500 terabyte license on that in gold, sport, or platinum.
We won't complain.
So, and his budget to start was less than $100,000. I can say honestly, he paid for the proof of concept $50,000. Then everything rest, I paid off my own pocket just to prove it. If he would pay all the hours of Andy, of me, of co-rate, yeah, he wouldn't compete with $100,000. Wouldn't be possible. But of course, R&D is also something you can write off in your balance. So what did we answer to him as a solution? An Exenta HA cluster running on the shelves of hardware, standard hardware, Supermicro, because I'm doing Supermicro already for 10 years, but you can also do it on an Intel, a Dell, which brand you want. Then the Core-Rate SRX 2880 over Ethernet solution. That was the first time I saw 80 over Ethernet in production. I was very surprised of the performance, the latency, and the easy of implementation. You just plug in Ethernet cables and the performance goes up. 10 gigabit fiber optic switches, cabling, and with a less latency than 1 millisecond between sites was a must from Andy to have low latency between the sites. You can have 10 gigabit Ethernet on CX4, for example, between 2 devices, but you have to have low latency. That's the most important thing in the whole story is what kind of links do you have between the sites. That's because you started with 15 kilometers, we went up to 40 kilometers, and on the end it will be 120 kilometers in total. So it has to be very tied up. Very good quality of switching was very important.
Just like to add to that, as we go further distance, the latency in that solution, the initial 15-kilometer trial we had sub 1 millisecond or just sub 1 millisecond latency between the two sites.
Of course, he had to agree that it was first time done. So because otherwise he would say, I will pay 50,000 grand, 50 grand. No, he said, I want to be on paper that it can take a while, and he had time. So we need a lot of technical support from Nexenta and Corate to work together, because Andy was in the UK, Corate was in the States, customer was in Belgium. So troubleshooting a device and developing, to get it work, it's not so as easy as done. So Andy actually went only one time on site, I think.
Yeah, just the once.
Once, yeah.
Mm-hmm.
So now, once fully tested, customer goes to beta with a small production trial. Now, this is the situation that he's testing it with live machines to do backups and so on. So I can't do live demonstration today, unfortunately. We did it in Amsterdam, and actually we did a virtual machine was running, and we demonstrated that one side went down, so automatically the service has to fail over. In that case, we achieved to do, it was in 25-30 seconds, the whole fail over.
I think we've got some slides later on showing what we demoed in EMEA. Because we can't actually fail that service over live, we can't do the same demo that we did in EMEA here in the OSS presentation. I do have a canned demonstration from my laptop showing the failover between the two services, and I'll show you that. Yeah.
Okay, next slide. So this is the layout that we drew out with the customer. The first slides of this were a little bit on paper. Then we go on and go on and go on. And finally, this is the actual installation. I think hopefully I removed the IP addresses and the passwords. I think so, yeah. So, but what you see here is actually the two data centers with the core array boxes, with the head nodes, and everything, which lines do you have? Now, in this slide, you see only one link between those. Now, that is also something we changed. We doubled the dark fiber between the two data centers. So if one line goes down or a switch goes down, then you don't have to fail over. So it's still redundant as much as can. So we want to achieve 100%. Every link is doubled. Every link is, 100% HA. If you want some more information about that, you can have it on the slides report of Nexenta, or you send me an email, Andy an email. He will happy to inform you with more data on it. So because the newest slide you will see on the end is more exciting than this one, the new layout actually that was done. So these are performance stats, and let Andy talk about those.
So these are some raw numbers that we ran on the initial POC test between the 15-kilometer apart sites. That shows you some of the disk bandwidths at a 32K block test. That's from one client to the Nexenta store volume on the remote site, i.e. 15 kilometers away. As you can see, we had a write performance of about 713 megabytes per second. Those numbers include our caches turned on. Later on in the presentation, I'll show you some numbers with the caches off so that you can see what we're actually getting off of the raw disks. The rewrite number, 441 megabytes a second. The read performance numbers with the caches engaged, numbers are all up there. So as you'll probably agree, those numbers are pretty good for a stretched cluster. You know, you'd be pretty happy with those numbers with the cluster in the room that you're testing them from, let alone 15 kilometers down the road.
Next slide.
Yeah. Okay, so I'm going to talk to you about some of these slides. I'll swap over around. This is a quick test we did on the 4K I/O performance, showing the latency of the solution across the solution across the wire, and it shows the number of threads that we have running across the bottom, and then IOPS performance across the bottom. As you can see, both of the latencies stay pretty flat as we go up across the number of threads. I think I have another slide here which shows a bit better the solution. As you can see, the blue line is our read performance. This is to do with the read weighting that we do, where we try as much as possible to read from the local appliance. I don't know, many of you guys were on the training? Who was on the training? Show of hands. Right, so as you know, we check some every I/O. When we read from a mirror, we have a choice of reading randomly from the local. Generally in ZFS, we have a choice of reading randomly from either the local, from one side of the mirror or the other side of the mirror. What we do is we then checksum that block, and if it's right, we pass that through. If it's wrong, we go and read from the other side of the mirror. What we've done here is we've made some changes in the Next Center code for Stretch Metro Cluster that actually intelligently goes and reads from the local array if it possibly can. We checksum that block. Only if we fail that block will we go across the Stretch Metro Cluster to do a read on the other side, so that we don't incur the latency penalty of going across the WAN link all the time. We can't actually do that with writes. If we write to one side of the Stretch Metro Cluster, we have to go across the WAN link by its pure nature to write to the other side. It's an atomic I/O, it's real time. So as you can see, the write performance does incur some latency response time as we increase the number of threads, as the workload increases as we go across the wire. So what did that actually turn into with some actual performance benchmarks? I know from some faces in the room, some of you guys were at the EMEA conference where we actually did this demo live and we had the performance numbers. Local site performance for the demo we did. In Brussels, we ran up a 4K benchmark from a VMware client. We benchmarked and stabilized that benchmark at 25,000 IOPS at 4K in the Brussels site. So imagine the VM host machine is in the Brussels site talking to its local storage. We had the benchmark running at 32K as well, benchmarking 400 megabytes a second. Live in that demo in a room pretty much like this, we failed that over to the Antwerp site. The failover event took 25 seconds from start to finish. We're here, one of our products we have, our HA cluster, is done by the guys that write RSF. Some of them are around the show. I would encourage you to talk to them about our HA solution. That failover event took less than 25 seconds. The I/O on the client machine that we were monitoring live paused for approximately 10 seconds during that failover event. And basically, what happens is after that failover event happened and the other side of the cluster came up, the I/O continued from that client completely non-disruptively to both the benchmark and the VM host that was running that. After the failover event, obviously we have some time to catch up with the I/O that's going off. Stabilized again very quickly back to 15,000 IOPS. That's because we're now running over a disparate link across 15 kilometers to the other side. I believe the numbers that we ran here were pretty much similar for the 40-kilometer test case. The latency is actually not that much more due to the quality of the customer's link. The longer distance latency link numbers drop those down to about 12,000 IOPS over the longer link, but they're still very, very healthy numbers for a synchronous data link type performance. The 32K benchmark dropped down to about 300 megabytes a second off of that. But as I say, we're end-to-end checksumming everything that goes across the WAN. That's one of the unique things about our product when we deliver Stretch Metro Cluster. We're guaranteeing you your data integrity as you send that across to your other sites in real time for every single operation that we do to disk.
I was going to ask, what are the practical distance limits?
So the practical distance limits that we're going to have on Stretch Metro Cluster is a 12 millisecond round trip delay. If we start operating outside those bounds, we can have some disk timeout issues potentially. So that's the maximum latency that we would induce across that site. As you saw from the previous graph, you can see that our worst response time in milliseconds jumps up at 32 threads to about 8.5, 9 milliseconds. This is a canned demo. Unfortunately, it's not quite as impressive as the EMEA demo we did. There's a couple of things we can't do. First of all, as I said, the platform's now in production, so Roel's customer is actually running this now. Second issue we have is the wireless internet in the hotel isn't quite as good as it was in the one that we ran in EMEA for the demo. We were actually a bit shaky. We were deciding whether to do that demo live. We were going to do this talk in the EMEA conference, and Roel said to me about half an hour before the EMEA demo was due to go off, wouldn't it be really cool if we could demo this live? So we nipped out the back, did about 3 wireless LAN tests in the hotel in EMEA, went, that looks good enough, walked in the room and went, how would you like to see it live? And there was a big show of hands. So we failed the event over in that. For those of you that aren't aware of our cluster product, this is what it looks like, and I'll walk you through what's going on here. As you can see, this is running on my MacBook. So basically, we're starting off a copy on one of the DR sites. This is on the Brussels site. We're copying that file across. You can see the I/O going on. What we're going to do is we're going to cause a failover event here. What you'll see in the graph is you'll see the I/O drop as we fail the pull over to the remote site at Antwerp, and then you'll see the I/O pick up and the file copy pick up on the other side. So we're going to pick to fail over the pull. As you can see, we're going to fail that over to the other data center. As you can see, the pulls are actually in manual mode. The recommendation for our best practices is that you will want to have your clusters in manual mode between sites. You can have them in automatic mode between the heartbeats. Our HA cluster product runs heartbeats across at the disk level and at the network level. As you can see, the failover events happened. The pull's failing over to the other side. Here's the pause in the I/O. And what you'll see is the I/O and the copy continue in a second when that failover event completes. The pools now become available.
You don't have any stress anymore, Andy.
And as you can see, there's the I/O continuing once we've failed that pull over to the other side. And then what will happen is the file copy will pick back up on the other side. I'll go back to what I was saying. Basically, our recommendation is you have your pulls in manual mode. If you're going to fail over between physical sites, it's generally because something major has happened. You're generally going to want some sort of human intervention in that process if the issues that you're finding with your service is serious enough that you're going to want to physically try and move sites between your stuff. It's quite common we get customers going, I want automatic failover between sites. Generally, if the customer looks at the business case behind that, that's not actually the case that they would actually want to do that. So that's the video demo. As you can see, the pause in the I/O. It's not quite as impressive as the benchmark we ran in EMEA, but as I said, we're not in it. It's certainly less stressful. I mean, that was a heart-in-mouth moment. So, Stretch Metro Cluster from Next Center Store. Product marketing will be getting the information out to you fairly shortly. These are the approved backends that we have for the Stretch Metro Cluster design to go in front of Next Center Store heads. I'll talk a bit about the co-RAID solution. This is the upgraded version of the co-RAID solution that Roel delivered to Bennett. Any of you guys know co-RAID and AOE in the room? I can see a member of co-RAID staff here, so you're not allowed to put your hand up, Kaushik. If you don't know your own product by now, you're in trouble. So basically, it's the ATA over Ethernet standard. Now, the reason we've chosen this as one of the backends that we have available to Metro Cluster is because the protocol is incredibly lightweight. It gives us very, very good performance. It's designed to run over the Ethernet layer. And basically, it's a very, very lightweight protocol. So the latency and the performance issues we see over WAN-type environments actually is a great benefit and a great play into our Stretch Metro Cluster product. The second and third products you have here are a joint offering between Next Center and Supermicro. They are specifically designed bills of material from Supermicro, one of our technology departments, alliance partners, designed for delivering this type of product. The first product is a fiber channel solution for customers that have fiber channel infrastructure. The fiber channel product is a 36-bay high-performance array with fiber channel connectivity. We support 3 terabyte drives in that unit, so that's 108 terabytes per shelf. And it will come fully integrated as a deliverable product with everything you need customized as a back end for our Stretch Metro cluster. The third product is our fiber channel Ethernet, fiber channel over Ethernet connectivity product using Emulex cards designed for specifically that purpose as well if the customer has an Ethernet based link between their sites. As Roel said, the customer originally asked for 2 sites. They actually have 3 sites in Belgium. So basically, we worked very hard after we finalized the spec for our dual site Stretch Metro cluster. And we're announcing here our triple site Stretch Metro cluster. The reason we can do this is ZFS underlying within it has triple way mirroring. Okay? And that allows us to, at the block level, with the same checksumming we have in our dual site product, deliver 3 sites. So basically what that means is you can have your VMs hosted anywhere in your global or in-country infrastructure. You could have 3 discrete sites, and we're happy to listing Bennessol's 3 sites. So we have Brussels, Antwerp, and Oostkamp. Okay, and what we have is we have dark fiber links, as Roel said, between all those sites. We deliver the co-RAID infrastructure across the back of those, where any one of the clusters can actually see any of the storage anywhere in the complete customer's WAN environment. We deliver that out block or file out via virtual IPs to the customer's server environment that you see at the top. And the whole infrastructure means that we can move VMs or we can move the customer's live environment anywhere between any of the 3 infrastructure sites that the customer has. And the data is real-time, atomic, checksummed at every single site. There's no asynchronous replication going on here. There's no time delay. There's no option for split blame. The data that is on all 3 sites is atomically correct at any point in time across the customer's complete WAN infrastructure. I think that's all we have for you right now. If anyone has any questions, I'll take any questions on Stretch Metro Cluster. How do we get the data synced back? The way ZFS works is we have a birth time for every transaction. It's a transactional file system operating system. One of the problems with traditional Stretch Metro clusters is once the caches on the synced sites go out of sync, competing products have no choice but to send the complete data from one site to the other. Now, if that's 108 terabytes array, you could be resyncing sites for days, weeks. Okay. We don't actually have that problem within ZFS in that we will only resync across to the other site stuff that's changed since the birth time between the 2 sites. So if the transaction group number at one particular site was transaction number 10,000 and we've processed up to 10,500, we're only going to send those 500 transactions back across the link to get those pools back into sync.
To actually scan all the blocks looking for one's version number or something?
Once again, we're a copy on write file system. So we have transaction times. Every atomic transaction that we put down to disk has a birth time and a transaction group number. And it's that transaction group number that we look at with the blocks that we have in the file system that we call Uber blocks for the guys that were on the training. We look at those blocks. That's how we know what blocks have changed. We can look at the transaction groups and we know what transactions that we have to ship or what blocks we have to ship from one site to the other.
Since you're synchronously writing blocks out to all 3 data centers, do you have limitations on what kind of loads the customer can run?
Yeah, I mean, obviously there'll be some performance limitations, but as you saw from the numbers I delivered, they're certainly a lot higher than a lot of the replication technologies that you have between sites. Bearing in mind that WAN links are particularly expensive between sites, you're not going to have customers with lots of really fat pipes between sites. So we certainly have demonstrated that we've got near to saturation on the 10 gig links. 700 megabytes a second down a 10 gig link is, getting pretty close to saturation at that sort of block size for that type of link. And typically, I wouldn't expect many customers to have multiple 10 gig links between sites, but there will be some practical limitations in terms of what we can deliver. But as you can see, the IOPS numbers and the bandwidth performance for a stretch type delivery cluster are in the upper ends of what I've seen anywhere else in the industry. Any other questions? That would be an asynchronous replication type environment. Next Center Store is quite capable of delivering asynchronous replication. A lot of our customers use that for recovery time and recovery point objectives in their solutions, doing asynchronous replication. However, there is a market for customers who require complete atomic synchronization of their data between sites. And that's exactly what this product is designed to meet as a challenge. So if you're looking at Next Center Store as a product, you do have a choice of your recovery mechanisms, and we can run autosync as frequently as every couple of minutes to send that data across. But that data will never be the exact data that was on the site that went down, because there has to be some sort of buffering going on. That sync may not have completed. With this product, the data that is on the site in Brussels is the data that is on the site at Antwerp, is the data that is on the site at Oosterkamp.
How long does it actually take to get it to where it was before the
That would be the resync. That's a complete play on how fast the customer's link is between the site. Any DR recovery situation from any other type of environment is limited by the bounds of how fast you can literally ship the data between one site and the other site. Yep, how much data has changed. Like I said, if you completely lost all the appliances and the storage on one site was completely wiped out, you would be starting from clean. In that type of environment, what you would do is you would pick up that head and that JBOD, you'd move it to a data center where you are, you'd do a local sync, you'd move it out to the remote site, and then we'd start picking up transaction groups across the WAN. And that's the same for any of the other commercially available synchronous replication products.
I was going to say, one thing that is interesting about this is that we're going to lose 2 out of 3 sites and cover one site far faster than another.
Yep.
And we still will mirror, and we'll still eventually end up at the same point.
Correct. So did everybody hear that statement there? So what you could do is if we could lose 2 out of 3 sites, you could choose to fast replicate one site and slow replicate the other site, and you would have perfectly that choice with the transaction groups within ZFS.
What about scrubbing? How is scrub handled? Like, do you do a periodic scrub, or?
So basically, as part of the design proposal, is you wouldn't scrub as often as you would on local disks. We are looking at ways of potentially doing local scrub on local disks only, and that may be a choice, but you would certainly want to defer you wouldn't want to do a scrub every night on a remote volume across a WAN link. But bearing in mind, one of the things that ZFS gives you in terms of its checksums on the file system is your requirement to check your volume on a regular basis is certainly not as great as it is with other file systems that are commercially available.
And besides, you have 3.
Yep, and you have 3 sites, right? As Linda quite rightly points out. So if one site did have a scrub issue, we still have 2 reliable copies of the data to take from. The checksumming will be there. It is possible to potentially have a checksum error that you might wish to repair from the other side of the mirror. you're not going to detect that block until you actually do a read from that block. What a scrub does is it forces us to read the entire file system and then check that block.
So
Is that during the time you work with scrub, both sides of the mirror have some kind of check.
Yeah.
so we did extensive studies of this in a prior life. What is the optimum scrub interval? And of course, this is what I do. Yeah. It's all probabilities, so the answer is it depends. But we came up with some reasonable business boundaries for a typical business. In other words, someone who's maybe not moving money, perhaps, but they have a different threshold. But for a typical business, we kind of decided that once a year is good. And then, of course, that's not very sellable, right? So if you tell someone, oh, we'll scrub the data once a year, they get all nervous. And so once a quarter is pretty decent. Once a week is way too often. So somewhere up to a year, we're pretty happy. Once a quarter, I'm real happy with. And it's all a matter of playing probabilities. You know, it's if you're a baseball fan, you do stats. You know, what's the chance of you hitting 3 home runs in a row? Well, you know, there's some way to gauge that probability. And with scrub analysis, we do the same sort of thing. So for traditional enterprise class equipment, which is what we're discussing here, you shouldn't have to scrub very often.
And the answer always is it depends on how often the data is being read. So every time you read, you're doing a scrub on that piece of data. Actually, one of my friends was the person who does the ZFS best practices site, and on there it says, I think it says once a week. And I asked her why once a week, and she goes, oh, well, we just guessed. We just, So I think Richard's numbers are much better because it really does depend on how much you're reading that data. If you're reading it all the time, you're scrubbing it as you read.
So have we actually looked at perhaps setting copies to 2 or more, and whether or not that had any impact on this design?
So the impact in terms of performance based on the latency seemed to make no difference between sending a 2-way mirror to a triple mirror. Bearing in mind the latency between the 2 sites was pretty much identical.
Yeah, no, I was actually thinking about setting number of copies on a data set.
Okay.
So say
yep.
we don't want to scrub, right? We want
Yep.
additional security.
So I don't believe we have run the performance numbers on setting number of copies to 2. I'm guessing we would have some sort of performance impact on doing that, but we don't have the data across the Metro cluster link yet.